Hi, my name is Michael Harmon, and this is the Thinking Man's Universe, Part 1, The Rules of Discovery. It's a modification of the Big Bang based on Bayes' theorem that allows us to remedy a certain pathology we've had in our cosmologies ever since the Greeks. It's presented in three parts. 1, the Bayesian extent of the universe. 2, the Bayesian structure of the universe. And 3, the Bayesian progression of our misconceptions. Enjoy. Part 1, the Bayesian extent of the universe. So what's Bayes' theorem and how is it going to help us with the extent of the universe? Well, Bayes' theorem is a probability theorem that uses accumulated confidence. If we were to see 2 sunrises in a row, we might say, well, I bet there's going to be another one. But if we were to see 30 sunrises in a row with no descending data, perfectly uniform, we would go, you know, this is probably going to happen thousands of more times. This is Bayesian logic. In terms of the extent of the universe, we might say that, well, with the discovery of ever more distant objects, the universe, our estimate of the universe gets larger and larger and larger. So that's our series of sunrises. Starting with the Greeks, they might have thought the universe was, oh, say, 10 billion miles across. Turns out that that's 2,400 times smaller than the distance to the nearest star. It's 1.3 billion times smaller than the distance to the furthest objects the Greek could see for themselves, and fully 8 trillion times smaller than the farthest object we found today with no end in sight. We've had 8 trillion sunrises since the Greeks. This makes us enormously confident that the universe is not only large, but trillions of times larger than the part of it we already see. This is Bayesian logic. In the small direction, the same is true. Based on high-energy collision data, the electron is still 1 trillion times, the largest an electron could be is still 1 trillion times smaller than the clay powders of the Greeks' times. This tells us the same thing in the small direction. The universe is virtually infinite, and we should consider it that way. This is what history tells us, and this is what Bayes' theorem tells us. Part 2, the Bayesian structure of the universe. Committing to the idea of an infinite universe removes certain pathological misconceptions that we have had ever since the Greeks at the very periphery of our knowledge. And we can do so by applying Bayes' theorem to the structure of the universe as well as to its extent. So what is the structure of the universe? What do we see here? Well, we see little stuff coming together to make bigger stuff, and then that bigger stuff coming together to make even bigger stuff and bigger stuff and bigger stuff. This is called the hierarchy of the universe. And we have long noticed that it is consistent throughout the full spectrum of the universe. From quarks to galaxy clusters, little stuff comes together in a profusion to make bigger and bigger stuff. Quarks make neutrons and protons. Protons and neutrons make nucleus. Nucleus added with electrons make atoms. Atoms come together to make molecules. Molecules come together to make all sorts of objects, from flatworms to physicists to polymers, you name it. And then they get big enough to make planets, and planets come together to make star systems. And then star systems come together to make galaxies. And then galaxies come together to make galaxy clusters. And the receding galaxy clusters we see all around us in the visible universe imply the structure of the Big Bang. The biggest structure we see is the expanding motion of everything we see. The hierarchy is unambiguously continuous across 40 orders of magnitude. That is, the visible universe is 1 with 40 zeros behind it times bigger than the quark. Perfectly symmetrical, no descending data, it's hierarchical. Yet, what do we do at the smallest and largest thing we see? We say, well, gee, we see the largest thing, that's the largest thing that exists. And see, we see the quark, that's the fundamental particle. Wrong, clearly wrong. A Bayesian examination says that these are just the farthest thing we can see in the hierarchy, that the hierarchy is infinite as well. It's unambiguous. There is no dissenting data. We should adopt this. There are 2 rules that we can apply that will make us stop making these mistakes at the largest and the smallest object we see. One is called the finite rule. The finite rule says that any physical phenomena you can identify, whether it's a behavior or a structure, is finite in extent and constituent to a larger structure. This is true across all 40 orders of magnitude of any item you can see, except for the largest item we can see, the Big Bang, and we just don't have the perspective to decide whether or not it adheres to the finite rules. The other rule is the plurality principle. We should never see any object as unique. No matter where you look in the universe, if you can identify a material phenomenon, you can find another incidence of it somewhere else in the universe. The plurality principle. All material objects are multiply manifest. This is true across the entire spectrum except for the largest object we can see, and we just can't see any other incidents of it. But if you know, in the next section, we will apply a Bayesian examination of the sequence of our cosmologies in the same way we applied it to the structure of the universe and the extent of the universe. It will be shown that every cosmology since the Greeks failed in precise resistance to the two rules of discovery. It will be shown as well that each new cosmology corrected the old cosmology's divergence, but adopted a new set of its own. And finally, we will show how a Bayesian philosophy corrects this pathology in the human search for knowledge. Part 3, the Bayesian progression of our misconception, starting with the first flat Earth cosmology ever devised and continuing all the way through to the Big Bang. We see a repeating pattern of misconception identical in every cosmology we've ever devised. We take the largest object we can see and we imbue it with two properties. One, that it is the largest object that exists, and two, that it is unique. Both are understandable at first when we first started examining things, but now they become a little less obvious. First we started with the Earth. We thought the Earth is the biggest thing, period. Obviously, it goes on forever, and those are just little things up in the sky. So the Earth is the sole unique object of its size, and the rest are ancillary, and that's the complete picture of the universe. We found out in due time that the Earth was only one of many planets, and not even the largest ones, that all were not unique and not the largest, and they all came together and made a bigger object, the solar system. Then we looked at the sun. Clearly the biggest thing anywhere. A bunch of little specks in the sky, and the sun. It's obvious. The sun is enormous, and it's the center of the universe. It is the biggest object in the universe, and it's unique. It was neither. We looked out and we noticed, well, the stars, those are actually other little suns, aren't they? Yes, they are. And they were all gathered over in this part of the Milky Way here. They're all, and we realized, oh, wow, we're in a galaxy of suns, just millions, billions of them all swirling around this one center. Cool. That's the island universe, they called it. It was the new, largest, unique structure in the universe. And it was a complete view of reality at the time, an island universe. It was an island of stuff in the void. However, we noticed that little nebulae we'd see inside our galaxy wasn't inside our galaxy at all. There were other little galaxies way, way off. So once again, it was not the largest, nor was it unique. There were billions of galaxies scattered throughout the part of the universe we could see. And they would cluster in little clusters, but all those clusters were receding from each other. Every one of them was going away from us, and therefore every one of them was going away from each other. So we thought, wow, at one time they had to be big, all close together. If they were all moving away, one time they were right, and boom, the Big Bang was born. Sure, that's what happened. It was one, we were all close, and then we blew apart. So that's the new, biggest, unique structure in the universe. Clearly it is neither. Clearly the Big Bang is ultimately a finite constituent to a larger structure and multiply manifest. There are other Big Bangs out there, and the Big Bang is just a small part of a larger structure. Take it to the bank. This Bayesian truth is almost inevitable. Sure, it will be an enormous structure, the Big Bang, but eventually it will dissipate and give way to a larger structure. The interpretation of the data is unambiguous. After 40 orders of magnitude of seamless adherence with zero deviation to an ongoing hierarchical structure to the universe, and after 5 cosmologies failing in precise resistance to this ongoing hierarchy, whose each correction corroborates the hierarchy, it is time for us to realize that we are studying at least a virtually infinite hierarchy. This is unambiguous. Unfortunately, humans want to answer the whole question. They want to feel like we are sufficient to describe the whole universe. The universe that evolved us is much more involved than we are capable of understanding. We must relegate ourselves to looking at the data as a set of local relationships in an infinite ongoing hierarchy. This not only allows us to interpret data we do have properly, but it allows us to anticipate the next phase of the hierarchy. This is what history tells us, and this is what Bayes' theorem tells us. Thanks for listening. My name is Michael Harmon, and this has been The Thinking Man's Universe, Part 1.